Hello everyone. In my previous video, I talked about the determination of E upon M ratio, and then we talked about the determination of charge of electron. Now the charge to mass ratio of an electron is 1.758820 into 10 raised to the power 11 coulombs per kilogram, and charge on an electron was determined by Millikan's experiment, and the value came out to be minus 1.6 into 10 raised to the power minus 19 coulombs. Now from these two things we can determine the mass of electron. So the mass of electron was determined by combining the results of Thomson's experiment and Millikan's oil drop experiment. How we determine? We determine it simply by dividing. So E upon M will give you the mass of electron. So which comes out to be 9.10 into 10 raised to the power minus 31 kilogram. So from here we can conclude that electrons are the fundamental particles present in an atom which carries 1 unit negative charge, that is minus 1.6 into 10 raised to the power minus 19 coulomb, and negligible mass, that is 9.1 into 10 raised to the power minus 28 grams or 10 raised to the power minus 31 kilogram, which is 1 upon 1837 times the mass of an atom of hydrogen. Now electrons are the universal particles, and electrons, they can be originated from number of ways. The few common sources are: number 1, from a heated metal filament; number 2, by exposing active metals like sodium and potassium to UV radiations; number 3, from radioactive substances in the form of beta rays. Let us now talk about the discovery of protons. Protons were discovered by Goldstein in 1886, but it was discovered in the almost similar experiment as conducted by Thomson in Crookes tube. He also took a long discharge tube, but he modified this experiment. How he modified? He made the anode as such, means in a solid form he took the anode, but he made the cathode perforated, means having some holes, perforations. So here the cathode was perforated. A gas was filled in the discharge tube, which was about 60 centimeter long discharge tube. A gas was filled, the pressure was reduced. So on reducing the pressure, he observed a new type of radiations passing through the holes of the cathode and moving in the direction opposite to the cathode rays. These rays consisted of positively charged particles moving away from the anode, and they were named as positive rays or anode rays or canal rays. So why they were called canal rays? Since they passed through perforations, since they passed through canals, through holes which were also called canals. Since they passed through canals, so they were called canal rays. Now the question arises, what is the origin of these anode rays? So anode rays are positively charged particles which constitute the anode rays. But how were they generated? They were generated when electron from the cathode knocked out, and it knocked out the gas particle taken inside the discharge tube. So when that electron struck at the gaseous particle, then that gaseous particle gets ionized. For example, if the gas taken in the discharge tube is M, so when electron will strike, it will ionize the gaseous particle M, So M gets converted into M positive and electron will be again knocked out. Now all this M positive is nothing, it is the positively charged particle, and group of such positively charged particle were nothing, they were the just anode rays. So one electron strike at the metal atom, at the gaseous atom, to form gaseous ion, and by this way all the electrons they strike at the gaseous particles to get converted them into the gaseous ions. These ions they originated in between cathode and anode, and they started moving towards the cathode. They were not generated at anode. They were generated in between cathode and anode, and they started moving towards the cathode. That's why these radiations they are called anode rays. So there are few characteristics of these rays. Number one, unlike cathode rays, positively charged particles depends upon the nature of the gas present in the cathode ray tube. These gases are simple positively charged ions. Now what does it mean? Suppose we take hydrogen in the cathode ray tube, in the CRT tube. So hydrogen when ionizes, it will be forming H positive plus E negative. Mass of H positive is 1 unit, and the charge is also 1 unit, 1 positive. Now if we shift to helium ions, means helium gas, helium will be taking off 2 electrons. So it gets converted into He2 positive. So mass of helium is 4 unit, but the charge carried by helium ions is 2 unit. So that means here charge as well as mass is changing. So that's why these positively charged particles depends upon the nature of the gas present, and their charge to mass ratio is different for different gases. Now some of the positively charged particles they carry a multiple of the fundamental unit of electrical charge. As I just explained that helium carries 2 unit charge, means 2 times the charge carried by the hydrogen. So these anode rays they have got the characteristics opposite to the cathode rays, but definitely few properties are similar. That is, number one, they travel in straight line. Number two, they consisted of material particles. Number three, they are deflected in electric and magnetic field. Now these 3 properties are very much similar to the cathode rays, but definitely they get deflected in electric and magnetic field opposite to that of cathode rays. Number 4, the nature or E upon M ratio of anode rays depend upon the nature of gas present in the CRT. They are simply positively charged gaseous ions. The positively charged particles carry charge equal to whole number multiple of the fundamental unit of electric charge. Now see the value of E upon M ratio. Since it depends on the nature of the gas taken in discharge tube. So when we take hydrogen gas in the discharge tube, this E upon M comes out to be maximum, and that is 9.58 into 10 raised to the power 4 coulombs per gram. Now why so? Because hydrogen is the lightest element. So that's why the E upon M ratio will be maximum for hydrogen. Now next is determination of mass of proton. Now next is determination of mass of proton. Now determination of mass of proton was calculated again by dividing the charge by charge is to mass ratio. The charge of proton was calculated very much similar to the charge of electron, and E upon M ratio was also calculated similar to the E upon M ratio for the electron. As Thomson did, whatever he discussed, whatever he did, by the similar method, the similar type of calculations were done for the anode rays. So by simply dividing E by M, we got the mass of a proton. So mass of proton came out to be 1.67 into 10 raised to the power minus 27 kilogram, or 1.67 into 10 raised to the power minus 24 grams. So from there we can conclude that the protons are the fundamental particles in an atom which carries 1 unit positive charge, that is 1.6 into 10 raised to the power minus 19 coulomb, and 1.67 into 10 raised to the power minus 24 gram mass, equal to that of hydrogen atom. So that's all about the protons. So here is the difference between cathode rays and the anode rays in a tabulated manner. In context to motion, type of charge, particles, quantity of charge and mass, and the origin. Let us talk about the discovery of neutrons. Now, discovery of neutron, actually the credit goes to Chadwick. Till 1920, no neutrons were not discovered, but scientists knew that atom is neutral. According to Dalton, atom is always neutral. So since atom is neutral, so that's why electrons and protons were discovered. And electrons carried negligible mass, whereas protons, they carry certain mass. And that means the mass of, if an atom carries only two things, there are only two fundamental particles, one is electron and proton, and electrons do not carry any mass. So definitely the mass of atom is the mass of protons. If it is so, then it should be applicable to all the elements. But when we apply it, it will be applicable only to hydrogen. For example, hydrogen has got one electron and one proton. That means the mass of hydrogen atom should be equal to the mass of one proton, that is 1 U. Now, the moment we shift from hydrogen to helium, helium has got 2 electrons and 2 protons. So that means the mass of helium atom should be equal to 2U, means mass of 2 protons. But actually the mass of helium is 4U. So from there it was concluded that there are some other fundamental particles present in an atom which do not carry any charge, but they carry mass equal to the mass of proton. So Chadwick in 1932 conducted an experiment. What he did, he took the source of alpha particles. Alpha particles are helium nuclei having 2 unit charge and 4 unit mass. 2 unit charge and 4 unit mass. So he striked alpha particles on the beryllium foil. And when he struck the alpha particles on beryllium foil, the new type of particles were generated. These new particles did not carry any charge and they were just the neutrons. In order to determine the mass of these particles, he placed a paraffin wax sheet in front of them. The moment these neutrons struck at the paraffin wax, they produced protons. Now protons are, as compared to electrons, protons are heavier particles. So if protons were removed or protons were generated, only the particles having almost similar mass to protons can generate the protons. So that means from there he concluded that the neutrons were released by the beryllium foil. And these neutrons, they do not carry any charge, they are neutral particles, but for sure they carry mass, which is almost similar to the mass of proton. So from there he defined neutrons as fundamental particles present in an atom which carries a mass of 1.675 into 10 raised to power minus 24 gram and no charge. This mass is slightly greater than the mass of a proton. Now what he did, he repeated his experiment. Instead of now the beryllium sheet, he took boron sheet, and again alpha particles were striked. Again neutrons were generated. How he came to know that neutrons are neutral? Because these particles did not show any deflection in the electric or the magnetic field. They went undeflected. They didn't show any deflection. So from there he concluded that neutrons are the neutral particles.